Hey everyone, Mr. Golden here. We are back at it for lesson 9 in unit 10, and today we're going to be solving rational equations. And so this is the first time in this unit where we're talking about actually solving rational equations. Remember, rational just means fractions, right? And so when you put all this math language together, here's essentially what's happening. If I gave you something like that, which is, you know, as a proportion where you have two equal fractions, this fraction is supposed to equal this fraction, the method in which you can solve this is by cross multiplying, right? 7 times x would be 7x, 5 times 2 would be 10, we divide both sides by 7 and we get 10 sevenths, okay? I'm going to take that same little example that we have just done and show you a different way to go about this. I think this is probably something you haven't learned a ton, but it eliminates, I'm going to write this down, it eliminates the denominator, okay? So yes, you can cross multiply, but when some of the problems that we do today, I think this method up here that I'm going to show you is going to be a little bit easier for you, my opinion, only. What you do is you take a look at the denominators of both, 5 and 7. And you figure out what the LCM is, or the least common multiple of both, which would be 35. And so what you would do then is you would times the least common multiple by every single fraction in the problem. And watch what happens. 35 and 5 reduce to 7, so you just are left with a 7 times an x because this 5 is gone, so you'd be left with 7x. This 35 and 7 reduced to 5, and so 2 times 5 would just be 10. And notice how my denominators were eliminated. And so now you just divide by 7 and you get x equals 10 sevenths. So we got the same thing, just a different method. And again, that's by multiplying every single fraction by the LCM. If you do that, it eliminates the denominators and you don't have to worry about cross multiplying, okay? This video could be a little long just because of the word problems at the end, so I'm going to try to bust through these early problems, not too quick, but quick enough. So when you look at something like this, you can cross multiply this. In fact, I'll show you how to do it with cross multiplication. So you'd basically have 6x times x minus 3, and then 1 times x squared minus 9. Okay? We would get 6x squared minus 18x equals x squared minus 9. And I would solve for x. Remember, we're solving, so I'm going to get 5x squared minus 18x equals negative 9. And what do I have? I have a quadratic. So I need to add 9 to the other side. So 5x squared minus 18x plus 9 equals 0. And then we're doing some factoring here. So I'm going to get 45. And so two numbers that multiply together give you 45. Add together, you get 18. So let's do some trial and error here. So let's see, 45 divided by 15 and 3. There it is, 15 and 3. So negative 15 and negative 3. Negative 3 times negative 15 is positive 45. Negative 3 plus negative 15 is negative 18. We add our x's in there. GCF going across 5x, going across negative 3 because that box is negative. Going up x, going up, that would be a negative 3. So this factors into 5x minus 3 times x minus 3. Now again, this is equal to 0. We are solving, solving, equal to 0. So then I need to set each of these equal to 0 and solve. So we know that's going to be positive 3. And then we know that this is going to be 5x equals 3 because I'm going to add 3 to the other side, which would be 3/5. Okay? It's always a good idea to check for extraneous solutions by plugging these in to make sure that what you're getting is correct, but these are our answers for this problem. Okay? Turn the page here. So here's an example where if you wanted to cross multiply, you would first have to get a common denominator here with the 5x and the 3x, and then cross multiply. So this is where I'm going to use that alternative method that I showed you on the first page. So what I'm going to try to do here is find the LCM of all fractions in the problem. Okay? So this fraction, and this fraction. What's the LCM? It looks like it's going to be 15x, right? And so what I'm going to do is I'm going to times each fraction it doesn't matter where you put it, by 15x. And you're going to cross reduce on these diagonals right here. So what's 15x divided by 5x? Well, 5 cancels out, goes into 5 once, into here 3 times, x crosses out, so all I'm left with is 3 times 3, which is 9. This x crosses out with that x. 3 goes into 15 5 times. 5 times 4 is 20. Okay? Equals 3 goes into 15 5 times, so I still have the 5x, so that equals 5x. And so now I just get negative 11 equals 5x, and I divide both sides by 5, and x equals negative 11/5. That's way easier than getting a common denominator and then cross multiplying, but you could do that if you chose to do so. Okay? Questions on that? Hopefully that was okay for you. I know these can be a little crazy at times, but hopefully we're getting there. So let's take a look at one that's a little bit more challenging. So if I'm using that method that I used before, where I'm thinking, okay, what's my LCM? What should I probably do on this problem first when you look at the denominators? Ooh, I probably gotta factor everything first, right? When you look at number 2, really didn't have to, I could pick out my LCM pretty easily by looking at the denominators, but here, I'm probably gonna wanna rewrite everything. So I'm gonna factor out an x out of the bottom, I'm left with x minus 5. That x can stay. Over here, I know I can take a 2 out of the bottom, and now I can have everything in factored form and say, okay, what's my LCM? Well, by looking at this, it looks like my LCM is going to be 2x times x minus 5. That looks like my LCM. So then I have to figure out, okay, what do I have to multiply then? I'm going to basically take my LCM, which is 2x, x minus 5, and multiply that by every single fraction. And then I'm going to cross reduce with the denominators. So x minus 5 cancels out, x minus 5 cancels out, that x cancels out with that x. All I'm left with is 2, so 2 times 7 is 14. Over here, this x crosses out with that x. So really I'm left with 2 times 2, which is 4, times x minus 5. Over here, this 2 crosses out with the 2, the x minus 5, the x minus 5, but I'm still left with the x, so that equals 3 times x. So then I simplify. I'm going to have 4x, let's see, minus 6 equals 3x, so I'll subtract 4x over here. Negative 6 equals negative x, so x is going to equal positive 6. Okay? And you should plug that back in, check to see if it works. All right? That's how you do number 3. Now, getting into the word problems, I believe there's 3 of them, 4 of them. These are challenging, okay? These are pretty tough. And so I'm going to do my best to kind of go through these at a decent pace, but they can be very challenging. So, and I will tell you that a lot of the problems that you're going to see on the quiz or homework are going to be very similar in wording because these are tough. And so we're going to try to keep it basic for you as we go through these. So if you read the question, this aerodynamic covering on a bicycle increases the cyclist's average speed by 10 miles an hour. The time for a 75-mile trip is reduced by 2 hours. What is the average speed for the trip using the aerodynamic covering? So whenever I ever read a story problem, I'm always looking at what are they asking me for. They're looking for the average speed. What's very difficult about this problem is you need to understand that we're talking about distance, rate, and time. So you guys remember dirt problems from Algebra 1, right? Distance equals rate times time. But since I want speed, I'm going to solve this for r so that I can express the bike with the cover and the bike without the cover in terms of speed because that's what I want. So how would I solve for speed or rate? I would divide by t, and so rate would equal d over t. And so I have 2 situations here. I have, excuse me, the rate with the cover, and I have the rate without the cover. In this lesson, we are talking about equal fractions, right? We've been setting up proportions. So what we want to do is to be able to set these equal to each other. Now, here's what it says. The aerodynamic covering on a bicycle increases the cyclist's average speed by 10. So most students are going to want to put plus 10. But remember that we want with the covering and without the covering to be equal to each other. So if with the covering makes it 10 miles an hour faster, we don't want to put a plus 10 because that would be not equal to this. We want to put a minus 10. Think about it. If the rate was 50, okay, so this would be 50. This would be 50 minus 10, which would be 40. Okay, so we want them to be the same amount. So this would be the rate minus 10 with the covering because it makes the speed 10 miles an hour faster. Okay, everybody with me? It's a tough one. Now, what we want to do is express the rate in terms of distance over time. So what's happening with the trip is a 75 mile an hour trip. So 75 miles. We don't know how long the trip is with the covering. Okay, the time for the trip is reduced. The time for the trip was reduced by 2 hours. Okay, so this is 75 over x minus 10 equals. This is going to be 75 miles without the covering over x plus 2. Why is there an x plus 2 here? The time of the trip was reduced by 2 hours. So if x was 5, then this would be 7 because it took 5 hours. This took 7 hours. It basically took 2 hours less with the covering. So we got to put the plus 2 over here. All right. And now we have to solve this for x. That is our setup for this problem. So we put this over 1. We got to get a common denominator, right? Which is going to be our LCM. What's our LCM going to be? It looks like it's going to be x times x plus 2. So that's what I'm going to times everything by. So in here, those x's cross out. So I basically have, I'm going to distribute this 75 here for the sake of time. 75 times x is 75x. 75 times 2 is 150. This is a minus 10 essentially, so that's going to be minus 10x, okay? Right here, minus 10x, so that's going to be a minus 10x. Here's how I'm thinking of it. This minus 10 times x would be a negative 10x times the x plus 2. So I'm going to distribute this. This would be negative 10x squared, and then minus 20x, okay? Equals x plus 2 cancel out, equals 75x. Now this is a tough problem, A, for the setup, B, for how to solve this. So if I put everything together here, I'm going to save some time. I'm going to save you some time. It's 10x squared plus 20x minus 150 equals 0. It is a quadratic because it's got x squared. We want to set everything equal to 0. And what we can do is we can factor out a 10 here and get x squared plus 2x minus 15 equals 0. And then I'm going to solve this by going 10. This turns into x plus 5 and x minus 3, right? 5 times negative 3 is negative 15. 5 minus 3 is 2. These are set equal to 0. And I still have to solve. So I get negative 5 and x equals 3. Those would be my two answers. Now there is an extraneous solution here because we're never going to have, what are we solving for? Speed, right? And so we wouldn't have negative speed, so that one's out of the picture. Now, most of you are going to put 3 down, but we want to find the speed. Well, and it says, what is the average speed for the trip using the cover? So using the cover was right here. If we didn't use the cover, it would be, if I wanted to find the without the cover, it would be right here. So 75 divided by 3 is going to give you 25 miles per hour. And you can see the answers right there, 25 miles an hour. If you plug the 3 in here, 3 plus 2 is 5. 75 divided by 5 is going to give you 15. And that should make sense, right? Because we talked about speed. It has to be 10 miles an hour faster. 25 is 10 more than 15. So that's how it works out. This is probably the hardest problem on your notes. This is probably one of the harder problems we've done probably in this whole class. It is a tough one, okay? Let's see if we can try something that's similar to it on this next one. So we got a rowing problem. Joe's rowing rate is going downstream is 4 miles an hour faster than his rate going upstream. He can row 3 miles upstream in the same amount of time it takes him to row 5 miles downstream. How fast is his rate? Again, we're talking about speed, so we're going back to this idea of rate is distance over time. So what do we have? We have rowing downstream and we have rowing upstream, and we want to set them equal to each other, so we got to make these equal. Joe's rowing rate going downstream is 4 miles an hour faster. So we have to put a -4 on the rowing downstream to make it equal to going upstream, because we want these rates to be the same. So yes, it's 4 miles an hour faster. Most people, and you can put +4 over here. It's just a different setup. But I like to say, okay, he's 4 miles an hour faster going downstream, so I'm going to subtract 4 to make sure that the speed is the same. So that's the first thing, okay? And then now we got distance over time. Well, we got for the rate, we have what? We have 5 miles taking X amount of hours minus 4 equaling going upstream was 3 miles going X time. How fast? The hours we don't know. We don't know what the hours are, okay? And so now again we're going to solve this for X. So I could put this over 1. I could times everything by X because my LCM is just going to be X. So I can times that by X, times that by X, and times that by X. X is cross out, 5. Basically minus 4X equals, X is cross out equals 3. So I could subtract 5 from both sides. I get negative 4X equals negative 2. So X is going to be positive 1/2. Now, the question says how fast is the rate going up the stream? So I need to plug this for the upstream. This is rate upstream right here. And 3 divided by X, X is 1/2. We know that to be 6 miles per hour. And that should make sense, okay? If you plugged it in here, we would get 10. And 10 miles an hour we know is 4 miles an hour faster than the 6, okay? Moving on, we've got 2 more to go. So a little bit different situation here. We have a situation where we have, we're stuffing some envelopes, okay? So when we're talking about, we've been doing rate equals distance over time. Well, now we're not talking about distance, we're going to be talking about envelopes. So it's basically going to be envelopes over time. Rate or speed equals the envelopes over time. Tommy can stuff envelopes 3 times as fast as Bernie. Together they can stuff 5,000 in 4 hours. How long would it take for Bernie to do it alone, meaning to stuff 5,000 on his own? Okay, so basically what we have here is this. We have Tommy plus Bernie, because it says together, so Tommy plus Bernie equals how much, or together. So Tommy plus Bernie equals together. All right. Tommy can stuff 5,000 envelopes over X hours. Bernie can stuff Tommy can stuff envelopes 3 times as fast. So how do you express that in terms of X and in time? Most people who do it incorrectly are going to put the 3 here. Tommy can do it faster. If, let's say, X was 2. If Tommy did it in 2 hours, that means Bernie would do it in 6 because Tommy's faster than Bernie, right? Tommy can stuff envelopes 3 times as fast, so he can go faster than Bernie. So we don't want to put the 3 here. We want to increase Bernie's time by 3. Together, they can stuff 5,000 envelopes in 4 hours. They tell us that. We can put that in there. So now we need to solve this for X. Okay, so again, what's my LCM? My LCM, I look at all the denominators. It looks like it's going to just be 12X. So I'm going to times everything by 12X. And simplify. So now I get 12 times 5,000, 1, 2, 3, and I get 60,000. Plus, X's cancel, that becomes a 4. So basically 4 times 5,000, we know that to be 20,000. So 20,000 equals, 12 divided by 4 is 3. So I basically have 15,000 X. So I have 80,000 equals 15,000 X. So divide 80,000 divided by 15,000, and I get basically 5.3. Okay? And let's see. I have, how long would it take Bernie to do it? So basically 5,000, or this is going to be 3 times that by 3. and I get 16 because that's my x value of 5.5. But remember, it's asking how long. Remember, this is time. This was time on the bottom, so I got to plug that in for x. 3 times that gives you your 16 hours. Oops, my calculator was off the screen there. Sorry. Okay, last one here. We're talking about, let's see, Zach can mow. Okay, this lawnmower one. So Zach can mow. This is very similar to the one we just did. Zach can mow twice as fast as his brother Jacob. Together, they mow a yard in 3 hours. How long would it take Jacob to mow it alone or to do it alone? So again, we're talking rate is a ln L over time. This is what we're working with. So we have Zach, we have Jacob. We're going to add those together to get together. All right, so now we want to express Zach in terms of speed. So how many lawns did they mow? 1. How long did it take Zach? We'll talk about it in a second. Jacob had to cut 1 lawn, right? Together they cut 1 lawn. We know it took them 3 hours together, so we know that together part is 1 lawn in 3 hours. That's what that means. Well, Zach can mow twice as fast as his brother Jacob. So if Zach is x hours, we know this would be 2x because it's got to take twice as long for Jacob to cut it than Zach. There's your equation. What's your LCM? Take a look at the denominators, 3, 2x, and x. That's going to be a 6x, so I'm going to times everything by 6x. And start cross-reducing. X's are gone, I get 6. X's are gone there. 6 divided by 2 is 3. And 6 divided by 3 is 2, so 2x. So I get basically 9 equals 2x. Divided by 2, so I get 4.5 equals x. Okay? And then the question says, how long does it take Jacob to do it alone? So we got to plug that back in here for time. Remember, the denominator is time. Oops, off the paper. Denominator is time, so 2 times 4.5 is 9 hours. All right? Again, a lot of the problems that you're going to see on the assignments, homework, quiz, and tests are going to be very similar to the wording here. We want to try to keep it consistent because these are challenging to set up. All right? I know you'll probably have some questions on these, and that's perfectly normal. We can talk about them in class, and I'll give you some examples to make sure we can try them on your own as well. All right? Take care.